Okay, hello, Year 12. I've been shown a fancy piece of data that means, not data, goodness me, a fancy piece of technology that means I can share my screen with you all. So that'll be really useful. Now, a student from the class has asked for help on some of the standard deviation questions and from exercise 2E that I posted. Would have been the first lesson that I posted actually since the lockdown, so a while back, but they are difficult questions, so I thought I would have a go and try to go through them with you. So the student asked for number 5B, number 7 and number 8 from exercise 2E. So if you want to pause the video and go and grab your stuff, if you weren't sure about these questions, then now's the time to do it. Now I am writing on my screen with my finger, so my writing on this is probably going to look like a 3-year-old's, so I do apologise in advance, but I don't have one of those fancy pens, you know, that you can write on the screens with. So you've just got to go with it with me, please. So first of all, we'll start off with 5B. Now it asks you to calculate the mean and the standard deviation with your calculator. So that should be easy enough because you can just type in all this information, do what I taught you to do, or if you can't remember, look up a YouTube video on how to use your Casio calculator to find the mean and the standard deviation. And you should get, for part A, the X bar equals £10.22, and that your standard deviation is £1.35. Okay, so that's for part A. I've just skipped that out because you should know how to do that just on your calculator. Now part B is the confusing bit because there aren't actually any examples on this, I don't think, or not clear enough really on it. And how many students received an amount of pocket money more than one standard deviation above the mean? You need to use interpolation for this, but you're actually using kind of the inverse of interpolation to try and find the number. So instead of finding like a measure of location like the median or a percentile or a quartile or something like that, you've actually got that. Because it's asking you more than one standard deviation above the mean. So that's your location, one standard deviation above the mean. And you're actually trying to find the number. So if you remember the formula for interpolation, let me just see if it's up here still on the other flip chart that I've got going. It is, lovely. You'll see here that obviously this is for the median, but say we knew the median and we were trying to work the number of people that actually the total number of people or something like that, you would be trying to find n, wouldn't you? So that's what we're actually trying to do with these questions. We're actually trying to find n. So let's start part B. So the first thing we need to figure out is what is the number that is more than one standard deviation above the mean. So we just need to do the mean plus the standard deviation. So add those two numbers together and you get 11.57. Lovely. So that's actually our location. And that's the thing that we're going to actually substitute in to try and find n. So if I just scroll down a little bit. So let's think about the table up here. So it's 11.57. That means it's actually in the bracket of 12. Because the lower bound of 12 is £11.50 and the upper bound of 12 is £12.50. So 11.57 actually fits into this. So obviously to use interpolation, we need to do a cumulative frequency, so add up the frequencies as we kind of go along. So up to this point, which is what we need, is I think it's 65. And then obviously the total number is 85. So they're two numbers that we need for when we're substituting into the formula. So let's go down and see how we can kind of figure out this formula. That's too far, goodness me. Right, let's go back up. So what we've got, when we've got our formula, we've got 11.57 is equal to something. Now, remember, we need B first of all, and B is the lower bound, and that would be 11.5. Because remember I said the lower bound of 12 would be £11.50. The lower class boundary, I should say. Plus, well, this is what we don't know, N, take away the sum of the frequencies below, so that's going to be 65, and then over the frequency of the class, which is 20, multiplied by the class width, which is 1, which obviously won't change it, but you can just put it in if you want to anyway. So that's, you'll recognise this as the interpolation formula, but instead of finding your measure of location, you're finding the number instead. So if you just kind of rearrange that by subtracting the 11.5, multiplying by the 20 and adding the 65, you get that N is equal to 66.4. And obviously you can't have 66.4 people or children or whatever it is, so we're going to round that to 66 because you can't have 0.4 of a person. Now that is the number of people that are less than 1 standard deviation above the mean. They're less than, so it's all the people that are less than. It's 66 people have got less than that, and we wanted more than that. So what we're going to have to do is we're going to have to do 85, which is the total number, minus the 66, which gives us 19. And so there are 19 students that are more than 1 standard deviation above the mean. I did tell you that my writing was going to be like a 3-year-old, so I do apologise. I need one of those fancy doodly pens. Okay, so that is the first question. And the other 2 questions are actually really similar in style. So I'll do this one. Maybe I'll leave number 8 just so you can kind of go back and have a go at yourself rather than me doing everything for you. Okay, the important bit here, if I can just show you this bit here, is, goodness me, right, there we go. This bit here, the 90% of the parts tested lasted longer than 1 standard deviation of the mean. Comment on the accuracy of the manufacturer's claim, giving relevant numerical evidence. So they're claiming that 90% of their parts lasted longer than 1 standard deviation below the mean this time. So for part 1, I think you have to find your standard deviation and your mean. You could do that using your calculator. That's absolutely fine. But I'm going to kind of speed up the process a little bit here and give them to you. So we've got X bar is equal to 16.1, and your standard deviation is 4.69. Okay, so that's all good. We've got that. Now it says 1 standard deviation below the mean. So we've got, this time we've got to do X bar minus the standard deviation, 16.1 minus 4.69, which gives me 11.41 hours. Okay, so that's 1 standard deviation below the mean is 11.41 hours. The next thing we need to do is we kind of need to have a look at where this is. So 11.41 hours is obviously going to be in this bracket here. Now your lower bound of your lower class boundary is 10. This is quite a nice easy one because you don't have to think about what's halfway. And your upper class boundary is 15. Your class width is therefore 5. What else have we got? The sum of the frequencies below is just 5. So yes, and then we know the question tells us that 50 of the parts, so your total is 50. So that's all good. They've actually been very nice to you there. So let's have a look at how we can work out the rest of this. So we're going to need to use interpolation again, and again we've got our location. This is our location that we need. So 11.41 hours is equal to, now the lower class boundary was 10, and then plus n that we don't know, minus the sum of the frequencies below, which was 5, all over the frequency of the actual thing itself, which was 14, multiplied by the class width, which was 5. So rearranging all of that to find n, you get 8.948. Now, you could just say, kind of stop there and think, well, 10% of 50, because they're saying that obviously 90%, was it last longer or last up to? I can't remember what they were saying. But basically, they were saying 10%, 90% was. Now, 90% of 50 would be 45. And so really, you would want this n to be 5, so that it would add up to 50. So that really kind of doesn't work out, as 8.948 is obviously larger than 5. Or what you would have to kind of say, round this to 9. Ooh. Sorry, round that to 9. So that's 9 parts there. So they're saying that 9 parts, they're saying that 5 parts should last, but then actually this is that 9 parts don't. So they're kind of contradicting each other. So actually the claim is false. Now what you would say, so we could try and do it this way. So 50 minus 9 is 41. 90% of 50 equals 45. So their claim, oh my goodness, their claim is false. And that would be absolutely fine, as 41 is less than 45. So you've shown that their claim is false. Now, question 8 is exactly the kind of same thing, especially B, estimate the number of days in which the wind speed was greater than 1 standard deviation above the mean. Same sort of thing. Here you've got your upper class boundary, and here you've got your lower class boundary, just in case. Here you've got all the detail that you need to work out the mean and the standard deviation. Just in case you don't know, there are 30 days in June, if that helps you out. Right, I hope this has been helpful. I'm very much enjoying all this technology stuff. Let me know if it is helpful at all, and if you'd like any more of these, because these are very easy for me to do. They take me no time at all, and I really want to give you all the support that I can. So just let me know, please. Don't be shy. Give me an email. Okay. I hope you all have a lovely weekend. I'm still waiting on quite a few of you to send a picture of your work, so please do that as soon as you can. Otherwise, I shall be chasing up people and parents as well. Okay, have a lovely weekend. Enjoy. Bye-bye.